Hi there, this is a quick review on exponents and how to manipulate those, especially if we need to use them in certain equations. So this would be applicable in logarithmic equations if you're there. So if we have two bases that are identical, let's say we have x squared times x to the third. Our bases are identical and we're multiplying bases. We are going to add exponents. So here I would say 2 plus 3 and I would get x to the fifth. Okay. If we have, let's say, x squared raised to the third power, notice I just have one base there. So I'm really, if I wanted to write this out the long way, I could, and I could say x squared times x squared times x squared. But what happens if that 3 is a lot larger than 3? You wouldn't want to write it out if it was 15. So what is the trick here? The trick is that you're still adding, but if it's written as, up here, then what you're really doing is multiplying. So you can see that that ends up being the same thing. So this is going to end up being x to the 6 because 2 times 3 is 6. So this is called the power rule for that one. The next one I want to go over is if we're dividing. So again, same base. Let's say we have x to the fifth divided by x squared. Same base, but you're dividing these two bases. When you divide, you're going to subtract exponents. Let's see if this will be nice to me today. There we go. Okay, so all we're going to do again is keep the same base, and I'm going to say 5 minus 2 and get 3. So that's a quick review of just very, very basic exponent rules. What happens if we have something more complicated? So let's look at another example. Let's say I have an example that is 1 over x to the 9th all to the 4th. Okay, so there's a lot going on here because what I could do is I could write this as 1 over x to the 9th multiplied together 4 times. But if you think about that, that's actually going to be x to the 9th in the denominator 4 times, which would end up being like a similar thing to what we talked about up here with the power rule. So what is the shortcut for this one? Well, first, it is to identify all the exponents in the expression. So 1 has an understood exponent of 1, and x has this exponent of 9. And when I have the parentheses here, parentheses means multiply. So we're going to multiply exponents here. So I'm going to even multiply it by this 1 that's here for the base of 1. This will end up being 1 to the 1 times 4, which is 4, over x, and then I'm multiplying 4 times the 9. So I'm going to distribute that 4 to the top and to the bottom. So 4 times 9 is 36. Now we know 1 to the 4th still ends up being 1. So this one actually worked out okay for that one. But I will say that quite often we need to write this without it being in fraction format. So sometimes it may ask for positive exponents. And if that was the case, you would stop right there. If it wanted just everything written in the numerator, then this is how you would do that. If I was to take this x to the 36 up to the numerator, it's going to change that exponent to a negative. So this would actually be written as x to the negative 36. And then you can use it in whatever you need for a problem. Let's do one more example. So let's say we have an example that is 2 over x to the second all to the third power. So this is very similar to the one before it, but Instead of having a 1 in the numerator, I have a 2 in the numerator. So I'm going to assign a 1 as the exponent there. Then I'm going to do distributive property to get rid of parentheses. And we've done that. You probably have done that with distributing in linear equations and various other things. It's very, very similar with exponents. So I'm going to say 3 times 1. That's going to give me a base of 2 and an exponent of 3. And now I'm going to say 3 times 2. So this is going to be a base of x and an exponent of 3 times 2, which is 6. If this is what I had left, then what I would want to do next is simplify the number or the base that is an integer. So here 2 to the third would end up being 8 over x to the 6th. And this may be good enough for what you need. Maybe you have to write your answer with positive exponents. If so, that's the answer. But again, sometimes we want everything in the numerator. So if we wanted to convert this, this would be equivalent to 8x. But again, if I bring this x to the 6th up, I have to change the sign of the exponent. So I'm changing the sign of the exponent to -6. And then maybe I could use this to continue working whatever problem I needed. Okay, so that's a very quick review. There's probably other things that I didn't cover, but I hope this was helpful in whatever you need for your problems.